Merry time zone appropriate greetings to you. The topic of the hour is wrinkle-resistant textiles. This applies to both wrinkle-resistant cotton and wrinkle-resistant linen. A topic that is a little bit out of left field for me, just because I grew up working class and in a country where, at least in the places that I frequented, dress codes leaned more towards blue-collar workwear and simplicity rather than suits and ironing demands. But that in itself is interesting because I've found a couple different studies, both mentioning that rates of contact dermatitis reaction to certain chemicals, that is, having an allergic reaction to something touching your skin, found in wrinkle-resistant clothing are higher in Scandinavian countries compared to elsewhere. So this seems like the kind of thing that maybe I should have heard about as a Scandinavian. But what do I know? Anyway, iron-free, easy care, or wrinkle-resistant clothing, whatever you want to call it, is a treatment done, as far as I can tell, to cellulose-based fibers like linen and cotton especially. There are a couple of different treatments or methods that can be used, and one of the reasons that this video has taken me so long to make has been that I wanted to do a more detailed breakdown of at least one of those processes, but either I have not been able to find the right search terms for the research article databases, or the industry is really playing things close to their chest, because I could not find as much material as I wanted at all. If you do, or know of journal articles that do provide the information about the process that I'm wanting, please share. I would love to look into the actual nitty-gritty of the process in more depth. One method that was described from 1985 was the use of amide formaldehyde reactants to cross-link the hydroxyl group of adjacent cellulose chains. This means that whatever cellulose chains in the linen or cotton that are adjacent to each other when this reaction happens will be inclined to stay stuck together, meaning that you can lock in both wrinkle resistance and specific wrinkles or pleats with the same method. Your garment will then be inclined to keep those shapes even after it is washed and worn. The ensuing fabric will be coated in a thin layer of, in this case, an amide formaldehyde resin or polymer, which just means a long chain of the same molecules strung together into a chain. And while this resin is supposed to be pretty stable, we still see the release of formaldehyde from formaldehyde resin-coated clothing like this, either to the skin to enlist an allergic reaction or to the environment. There are over 30 known formaldehyde releasers like this, more complicated chemicals that release formaldehyde as they break down or react with other molecules, and we find them in anything from cosmetics and antimicrobials to lacquers, varnishes, and metalworking fluids. Side note, but my understanding from what literature I have been able to find is that this is not necessarily the most used method for producing wrinkle-resistant items for clothing, nor was it the only method at the time either, but again, literature searches to find more details have been scarce. And yes, we are talking about that formaldehyde, the one that historically preserved those jars of biological specimen of various kinds that you would often find in labs like that. A staple in lab interior, in the background, mad scientist's lab, those jars of just organs and animals and whatnot. That is formaldehyde, or formalin, because it's formaldehyde dissolved in water. Formaldehyde on itself is a gas and it's a very small molecule, but anyway, I digress. Formaldehyde is ranked as a carcinogen and has also been used as a preservative in mortuaries, as a fungicide and disinfectant for cabinet making and woodworking, and as a building block for polymers, which we touched upon, and many other interesting things. Formaldehyde also exists and is released naturally in our environment by things like forest fires, fruits, alcoholic drinks, and fuel combustions. Our bodies even have the capacity to produce it or synthesize it from other molecules, such as, for instance, by oxidizing methanol into formaldehyde by the enzyme methanol dehydrogenase. But this natural low level of occurrence has been part of the reason why regulating formaldehyde can be a bit of a challenge. But one guideline sets a total limit of exposure to airborne formaldehyde to 0.75 parts per million over an 8-hour working shift, or a maximum of 2 parts per million formaldehyde for a 15-minute short-term exposure limit. Interestingly, the odor threshold, or the minimum concentration when we start picking up the pungent smell of formaldehyde with our nose, is right around 0.8 parts per million, or right above that 8-hour working shift maximum of exposure of 0.75 parts per million. Though, hopefully, you wouldn't smell the formaldehyde if you were working with it the whole day, or you would have been exposed to significantly more than that. But yes, aren't you glad wrinkle-resistant fabrics and garments are coated in the same stuff we used to preserve body parts and other things in? Doesn't that sound like a good time? And not that it really counts for anything, but when I googled for formaldehyde, the textile industry may or may not use so much formaldehyde that it gets listed by the sketchy AI overview. Do with that unverified tidbit what you will. Formaldehyde is also one of the few chemicals used in textile and clothing treatments where we know it can be a potential skin sensitizer and allergen, and we have multiple studies backing that up. Formaldehyde can also be a significant source of the total number of contact dermatitis cases. In a study covering the year 1953 to 1962, the Department of Dermatology at Rikshospitalet in Norway went from seeing formaldehyde being responsible for about 1.9% of the annual number of allergic contact dermatitis cases that came to their hospital in 1953. That changed when, in 1961, they saw that formaldehyde was responsible for 23.1% of the total number of contact dermatitis cases that came to the Department of Dermatology. So almost a quarter of all cases that year were due to formaldehyde alone. This same study was also the one to notice that some people who are allergic to formaldehyde also contract contact dermatitis from clothing treated with formaldehyde, but others don't. So the example being that some people react to wrinkle-resistant clothing while other people who were just as allergic to formaldehyde had no issue with the same clothing. The researchers theorized that there may be some genetic factors at play related to what sort of chemicals are contained in our sweat and other individual details related to different conditions on and within different people's skin, so that some people had skin that better broke down that formaldehyde resin on the clothes, while others didn't. I thought this all sounded fascinating, especially as they theorized that this might also be why Scandinavian countries seemed to experience a higher than average number of formaldehyde-caused contact dermatitis cases. But sadly, I have not been able to find any other studies about this since this was published in 1963 that looked into this further. So, as with the other still unresolved mysteries I have mentioned before, if you know more about the issues of which I am speaking, please share thy sources in the comments down below. I would love to dig deeper and for all of us to have an opportunity to be a little bit more enlightened. I know, darling, there's a microphone cable, and it isn't for you. I'm sorry. And Formaldehyde in clothing is common enough and has been a problem often enough that Oecotex and the EU have established limits on how much formaldehyde can be present in clothing when spot tested, which currently stands at less than 20 milligrams formaldehyde per kilogram of clothing for babies and 75 milligrams of formaldehyde per kilogram of clothing for everyone else. The EU also restricts how much formaldehyde an item or piece of clothing can emit to the air around it, with the limit being 0.062 milligrams per cubic meter, sterling, for wood-based articles, furniture and car upholstery, and 0.08 milligrams per cubic meter from other articles such as textiles, leather, and electronic products. I find the latter very interesting because it cares less about how much formaldehyde is in a product as much as it cares about how much of that formaldehyde is actually released into the surrounding air that we live and breathe in. And formaldehyde is a small molecule that likes to exist as a gas, so measuring it in our indoor air and the like makes sense. Another way to look at it, based on 75 milligrams per kilogram, is that if we had a t-shirt that weighs 200 grams, it could contain no more than 15 milligrams of formaldehyde in total in the entire shirt, while a chunkier sweatshirt of, say, 600 grams may contain up to 45 milligrams formaldehyde before breaking legislation. And that is upon purchase of a new garment. Like many other chemical treatments, some of the formaldehyde embedded in our clothes can wash out upon laundry and use, which is good news for us if we use the same clothing for a long time, but less ideal for aquatic systems and the rest of our environment. Another thing to note, and something you viewers often remind me to highlight because these topics are so multifaceted, is that just because something is labeled organic, that does not automatically mean that it has undergone fewer textile treatment steps or contain fewer dyes and treatment chemicals overall. Organic cotton, for instance, denotes how that cotton was grown, what treatments and pesticides were allowed or not allowed, but organic alone does nothing to influence how that cotton gets treated once it is harvested and processed. One study from Spain found the highest levels of formaldehyde in their study to come from 2 black pairs of underwear, and they were both labeled as made from organic cotton. And although various chemicals can permeate the skin barrier all over the body, such as the father-in-law who bought a leather hat and developed skin cancer from the hatband against his forehead, there is a part of me that feels even more concerned when chemical exposure is happening in relation to mucous membranes or other especially sensitive areas on the body, such as in this case with underwear. It also bears to mention that organic cotton is one of the industries that are suffering significant levels of fraud due to the potential economic advantages, and it is something that has to be constantly monitored and managed. Fiber, textile, and garment production is still an industry that is a long way off being traceable from cradle to cradle as the standard, and frequent movement of goods between factories and third-party companies makes various kinds of fabric fraud incredibly easy to hide. But not to end us on too bad of a note, I want to talk about a lawsuit done by flight attendants of American Airlines against the manufacturer of their new uniforms. Said uniforms were causing them all sorts of health issues such as breathing problems, rashes, headaches, runny eyes, and sore throats. In a previous video on chemicals in high-performance clothing, I've talked about how the flight attendants of Alaskan Airlines in their lawsuit on similar ground and that fell through. And part of the reason for that was that no single chemical was above what had been determined as potentially dangerous exposure. And if you want to know more about why that is a problematic approach, I shall leave a link to that video in the description below. It was different for the flight attendants from American Airlines, though, because although the issue surrounding the cocktail effect of multiple treatments of functional chemicals in the same set of clothing, they had one distinct advantage in our current legal system. The formaldehyde levels in the American Airlines uniforms, when tested, were above what was considered safe threshold levels. This allowed the American Airlines lawsuit to be the first of 3 big lawsuits by flight attendants regarding their uniforms, making them sick, to actually be successful. And they were awarded over $1 million for their troubles. And if you are wondering why flight attendants specifically, it is not necessarily that flight attendants are inherently getting more dangerous uniforms, but rather the conditions within which they work. Flight attendants work in small, controlled environments, physically close to their colleagues who are also wearing the same uniforms in cabins that recycle air back to them. Many of the long-haul flights also keep them in those same uniforms in that same closed environment for significantly longer than 8 hours a day, meaning their exposure to their own uniform can be a lot higher than most other professions. But we have also seen cases where people are reacting to their workwear in other professions, such as a pediatrician who developed allergic contact dermatitis to formaldehyde from their hospital scrubs and mask. As such, I think we can look at flight attendants as early warning signs or canaries in the coal mine, because all health and safety legislation is very, very literally written in blood of the people who came before us. And as our community members who are struggling with conditions like multiple chemical sensitivity and mast cell activation syndrome, we are seeing more and more people reacting to the complex and at times concentrated synthetic chemical environment that we have built for ourselves out of relatively new chemicals that we are emitting into our own planet and that we don't fully understand the full impact of yet. Of these, formaldehyde and formaldehyde resins is just one of many chemicals that textiles and clothing are treated with to provide a range of different colors and features. And of course, though it feels worthwhile to mention it this time as well, if we are experiencing these reactions simply by wearing these clothes, which have comparatively low levels of chemicals in them by the time they reach us, imagine what it is like for the humans working at the garment factories or distribution centers themselves, where these chemicals may be applied or experienced in significantly higher concentrations. Do you think easy care or wrinkle-resistant clothing is worth it? As an addendum, on videos like these, I always get some people asking how they can know if there are specific chemicals in their clothing and what those chemicals are. We are not talking about fiber content here, for which there are various at-home tests like burn tests, ash behavior, bleach test, crinkle, feel, and fiber appearance, but rather those chemical treatments that may give those fibers specific features like stain resistance, sheen, wrinkle resistance, or similar. And for formaldehyde, we do have a few tests, although neither are terribly accessible at home. The first is something called Schiff's reagent, which tests for aldehydes, of which formaldehyde is one. It contains many chemicals that I wouldn't expect to find in most residential homes, such as sulfurous acid, parazoaniline, hydrochloric acid, and thionyl chloride. It is one of those fun color-changing reactions, though, and when done right, Schiff's reagent will go from pale yellow to bright or deep red, depending on how much aldehyde is present. Another alternative for detecting formaldehyde is the Nash method, which can be made more or less sensitive to formaldehyde specifically by making certain adjustments to the base reagent. But again, not made with ingredients you would commonly have access to outside of a laboratory setting, so I think of this more of a curiosity than anything else. We are still at the limit of having to have samples sent into a lab for testing, where they usually have to cut off a piece of cloth from the clothing and dissolve it, or at least the chemicals that is coated on it, for it to be extracted and tested and run through an analysis instrument for there to be any sort of information of what there actually is on these clothes. And even then, we do need to know what chemicals we are looking for. We can't just analyze for anything and see what pops up. That is not a time-efficient way to be doing things, certainly not cost-efficient either. It's just my teacup, darling. I know you don't like warm liquids. Don't worry. I shan't spill it on you. Thank you for watching this video, which has been in my project pile for years because sources have just not been forthcoming. But sometimes we just have to do the thing and share what we do have so that hopefully we can start a dialogue that will allow us to learn more about it in the future. If you enjoyed this video and want to see more videos like it, perhaps consider joining my amazing patrons. They really are the lifeblood of this channel and allow me to keep doing what I love doing, which is trying to highlight and inform you about things like chemicals in the textile industry, which I feel get very little coverage and general awareness. To bounce off these videos about chemicals in textiles, I have started a tentative series that we are calling Know Your Clothes, a campaign where, first of all, I need to learn how campaigns work, so follow along to see a complete newbie try their hand at that. But it is a campaign where the end goal is for clothing, and ideally anything, really, but perhaps let's not get too far ahead of ourselves. But I want clothing to be labeled as thoroughly as we write ingredient lists on cosmetics and food items. Clothing or textiles in some form or other sits against the biggest organ in our body, our skin, for most of the day and night. And yet we get no information about what is actually in said textiles beyond a bare bones and not always entirely accurate fiber content label. I think we can do a lot better than that. Know Your Clothes is still in its very, very early infancy, and I am taking tips and suggestions from you, the viewers, as I try to figure out what to do next. I imagine it will be an adventure that will take us many, many years, and I hope you want to come along for the ride. References, as always, can be found in the description box below. Thank you again for watching. Thank you to our amazing patrons and our growing, thriving community. And if you enjoyed this and maybe even want to see more, perhaps I shall see you again next time. For now, though, bye. Listen to this. No, you weren't supposed to eat it. You were supposed to purr into it. Darling.